Next, we're going to look at histograms, which are a good way to graph large data sets. They're really superior to box plots, stem and leaf displays, dot plots, etc. when the data set is very large. Basically, what it involves is grouping the data together into intervals or bins and then counting how many observations or data values are in each of those bins and then making a graph out of those counts. So the first thing you do is you construct a frequency table. This is where you divide the data into class intervals of uniform width, and then you count the number of data values in each class interval. The table is going to be made up of these intervals and these counts, and I'll show you an example in a minute. Secondly, you construct the graph. Now the graph is going to look like a bar graph, and there will be one bar for each class interval. The bars are going to be of uniform width, and they're going to touch unless the interval is empty. This is one way you can tell a histogram apart from a bar graph. Bar graphs apply to categorical data, and in a bar graph, you have a bar for each category of your variable, and those bars are separated by a little bit of space. With a histogram, you're dealing with quantitative data, and you just put the bars right next to each other, unless there's an empty interval, in which case there won't be any bar at all. Okay, the height of each bar corresponds to the count in that particular interval, and the area of each bar is going to be proportional to the count in its interval. Okay, this is a very important idea in statistics. When you're graphing data, you want to follow this principle, the so-called area principle, that the area that represents a particular count has to be proportional to the true count. Otherwise, if you don't observe this principle, you get distorted graphs, and it can be very misleading. Sometimes people make this mistake inadvertently, and sometimes people make this mistake on purpose. So when you look at a graph, you always want to make sure that the graph obeys or follows this area principle. It's a very important idea in statistics. Now here's an example. We've got the heights of 29 AP statistics students in inches, and you can see the data here. What I did was I looked at the smallest data value, which is 53, and the largest data value, which was 77. And I asked myself, how could I divide up the data into uniform intervals from 53 to 77? There's a difference there of 24 units, 24 inches. And if I want to make maybe 8 class intervals or something like that, I could divide those 24 inches by about 8, and then I'd get intervals that are roughly 3 inches wide, 3 inches across. That's basically what I did. So I have class intervals that run from 53 to 56 inches, 56 to 59 inches, etc. And then I counted how many observations would fall within each interval. Now, if I'm looking at this interval from 53 to 56, I would include a value of 53 in that interval, but I would not include 56. If I see a value of 56 in my data set, that would go in this interval right here. Okay? So I look across, I see, okay, there is only one 53. There's only one value between 53 and 56. And so I have a count of 1 in that interval. I don't see any values 56, 57, or 58 in here, so I have a count of 0 for that interval. From 59 to 62, I look around, I see, oh, there's a 60. That's the only one that falls in that interval, so I put a count of 1, and so on. The largest count is for the interval from 68 to 71 inches. There are 12 observations in that interval. And as you can see, we've got a count for each interval here. And one thing you want to do when you do this kind of frequency table is add these up and make sure that they add up to the total number of data values that we have, which should be 29. So we have 1 plus 1 is 2, plus 1 is 3, plus 6 is 9, plus 12 is 21, plus 5 is 26, 27, 28, 29, and we're good to go. Now what we're going to do is we're going to make a bar graph out of these counts. The class interval will indicate where the bar is going to be located, and then the count will indicate how tall the bar is going to be. Now when you do this graph, what you need to do, first of all, is to give your graph a title that says who and what for your data. Okay, these are the heights of 29 AP statistics students. Now, when you draw this kind of graph, you have to make sure that it's going to fit on your paper. So you're going to have a horizontal axis that represents your variable. In this case, it's height in inches, and it runs from 53 to 80, because each interval is 3 inches wide, and 77 is going to go in this interval right here. So I have to extend this x-axis, or this horizontal axis, out to 80. So I need to make sure that that's going to fit, and I need to scale my graph accordingly in case it might not. And then you need to have enough headroom in the vertical direction so that the bars don't bump up against the title. Okay, now my biggest count was 12, so I counted down from here so that I would have enough room to fit a bar of 12, and then I drew my horizontal axis. I drew my vertical axis that represents the counts. Then I put the bars in. I had one data value that was between 53 and 56, none between 56 and 59, one in each of these intervals, 6 between 65 and 68, 12 between 68 and 71, etc. And when you look at this graph, you can see, okay, it's a fairly symmetric graph except for this one observation over here at 53, and that stands apart from the data a little bit. That might be an outlier. If you want to work backwards from this graph and try to figure out where the quartiles are, or what the mean might be, or the standard deviation, you're pretty much out of luck. The histogram sort of hides a lot of the detail of the data. It's great for giving you a general overall picture of how the data look, but it's not very good for working backwards and finding summary statistics. So it's not going to be that useful in that way. You could figure out that the median is somewhere in this bar if you count 1. 29, half of 29 is, the middle value would be 15. So if you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, the 15th value is in this bar. So we know the median is somewhere between 68 and 71, but we can't tell exactly where. We can figure out that the first quartile is somewhere in this interval, but we don't know exactly where. The third quartile is in this interval, but we don't know exactly where. So we can't figure out what exactly the IQR is. We can't figure out what the fences are. We can't determine if that's an outlier or not. In order to do all of those things, you have to go back to the original data. And that's one of the drawbacks of a histogram, is that it glosses over or hides a lot of the detail in the data that might be useful. So you're going to have to work directly from the data in order to find all those summary measures, and then your histogram will give you a nice picture of the overall shape of the distribution. Now, if you want to do a histogram on your calculator, it's simply a matter of putting the data in. So you go to Stat Edit. I put the data in list 3 right here, and I have all my heights in there. And then you can quit once you have all the data in. Then go to second y equals to stat plot. Select the plot. Make sure it's turned on. If you're doing a histogram, you want to select on the type line this one right here. You see it's got the bars. And then your X list would be the list where your data are. Okay. Now this frequency list, you just set that to 1 in the case that you have the actual data values, individual data values in this list right here. If what you have are data values, and then you have another list with the counts or frequencies of those data values, then that list would go right in here. And then you can graph your histogram. Now, one thing about the calculator that is a little bit unfortunate is that the calculator decides what the picture is going to look like for you, and that might not be what you want. This matches the histogram that I drew by hand up above, because I set the window to fit that. My minimum value for x is 53, my maximum is 80. I set this x scale to be equal to the width of the class interval, or bin, which is 3 inches. And then I set my y, so I have some, minimum y is below 0, maximum y is well above 12, and then everything fits when I draw the picture. It looks very good. You could let the calculator set the window for you, and then you're sort of taking your chances. You can go zoom 9, and then the calculator will draw the graph for you, and it might not look quite the way you want it to look. So the calculator has a complicated formula for figuring out how it's going to draw these things, and it might not match your particular aesthetic sense, let's put it that way. So I recommend that you set the window yourself the way you want it, and then you can get the picture the way you want it to look.